and temperature. Before discussing about these terms, it is important to know what are potential and kinetic energies. Can you recall? Correct. The energy stored in an object is called potential energy, and the energy obtained from the motion of an object is called kinetic energy. Come, let us now know the difference between heat and temperature. In the previous grade, we learned that a substance is made of atoms. Atoms in a substance are always in motion. The total kinetic energy of the atoms in a substance is a measure of the heat contained in that substance, while the temperature of a substance is related to the average kinetic energy of atoms. Suppose the average kinetic energy of atoms in two objects is equal, then their temperatures will also be equal. The motion of atoms in a gas at high and low temperature is shown here. If you observe carefully, you will notice that the atoms are shown with arrows. Length of arrows is different in both the cases. The direction and the length of the arrows attached to the atoms show the direction and magnitude of the velocity of the atoms. Thus, it is clear that the velocity of atoms in the gas at higher temperature is larger than the velocity of atoms in the gas at lower temperature. Let us now have a look on the motion of the atoms in a solid substance. The atoms in a solid object are tied to one another because of the forces acting between them, so they cannot be displaced from their places. However, when heat is supplied to solid substance, the atoms in it oscillate around their fixed position. Their velocity of oscillation depends upon the temperature of the solid. Higher the temperature of the solid, faster is their velocity of oscillation. Come, let us now compare the heat content of two objects. Suppose A and B are two objects made from the same material, and the mass of object A is twice the mass of object B. This means that the number of atoms in object A is twice the number of atoms in object B. Suppose the temperature of both the objects is the same. That is, the average kinetic energy of atoms in A is same as that in B. Let us now talk about the heat content of object A and object B. As mentioned earlier, the number of atoms in object A is twice the number of atoms in object B. Thus, the total kinetic energy of atoms in object A will be twice that in object B. Hence, the heat content of object A is twice that of object B, even though they both have the same temperature. We know that when two objects, one hot and another cold, are kept in contact with each other, then both the objects exchange heat. The hot object gives away heat, while the cold object absorbs heat, due to which the temperature of the hot object decreases, while that of the cold object increases. We know that an increase in temperature of an object means an increase in kinetic energy of atoms. Thus, the kinetic energy of atoms in the cold object goes on increasing, while that in the hot object goes on decreasing. This continues, and after a while, a time comes when the average kinetic energies of atoms in both objects become equal. That is, the temperatures of both objects become equal, and the exchange of heat between two objects stops. You might have seen when someone at home gets high fever, mother puts folded cloth strips soaked in cold water on the forehead of the person. know the reason behind this? Correct. Wet strips soaked in cold water being at low temperature absorb heat from the person having fever. Due to exchange of heat, the body temperature of the person having fever decreases. Come, now it's time to perform an interesting activity. Activity. Let us take two steel vessels A and B of the same capacity. Now, let us pour a glass of water in vessel A and 2 glasses of water in vessel B. Let us now measure the temperature of water. Water in both the vessels are at the same temperature. It is 28 degrees Celsius. Let us immerse the thermometer in vessel A using stand. Now let us heat the water in vessel A using a spirit lamp till the temperature of water rises by 10 degrees Celsius. At the same time, start the stopwatch. Note down the time taken to raise its temperature by 10 degrees Celsius. Now let us heat the water in vessel B and start the stopwatch. Let us now note down the time taken to attain temperature of 38 degrees Celsius. Let us now compare the readings. We observe that more time was required to raise the temperature of water in vessel B. This means that for the same increase in temperature, we had to give more amount of heat to B. From this activity, we can conclude that even though the water in A and B have the same temperature, the amount of heat in B is more than that in A. After this activity, let us now know units of temperature. Temperature is measured in units of degrees Celsius, that is degree C, degree Fahrenheit, that is degree F, and Kelvin, that is K. Degree Celsius and degree Fahrenheit are the units of temperature used in daily life, while Kelvin is used in scientific experiments. Let us now see the relation between these three units. Formula 1. Relation between Celsius and Fahrenheit. F minus 32 upon 9 is equal to C upon 5. Formula 2. Relation between Kelvin and Celsius. K is equal to C plus 273.15. Here, some specific temperatures are given in 3 scales. Come, let us verify whether they satisfy these two relations. Also, let us fill appropriate numbers in the blank places. 1. We know that the boiling point of water is 100 degrees Celsius. Let us convert it into degree Fahrenheit using formula F minus 32 upon 9 is equal to C upon 5. Thus, F minus 32 upon 9 is equal to 100 upon 5. Therefore, F minus 32 upon 9 is equal to 20. Therefore, F is equal to 180 plus 32. Therefore, F is equal to 212 degree Fahrenheit. Answer is matching with the value given in the table. Let us now convert it into Kelvin using the formula K is equal to C plus 273.15. Thus, K is equal to 100 plus 273.15. Therefore, K is equal to 373.15 Kelvin. The calculated value is matching with the one given in the table. Next is freezing point of water. 2. We know that the freezing point of water is 0 degrees Celsius. Let us convert it to degree Fahrenheit using the formula F minus 32 upon 9 is equal to C upon 5. Thus, F minus 32 upon 9 is equal to 0 upon 5. Thus, F minus 32 upon 9 is equal to 0. Thus, F minus 32 is equal to 0 into 9, which is equal to 0. And therefore, F is equal to 32. The calculated value is matching with the one given in the table. Let us now convert it into Kelvin using formula K is equal to C plus 273.15. Thus, K is equal to 0 plus 273.15. Therefore, K is equal to 273.15 Kelvin. Let us correct the value in the table to 273.15. Similarly, room temperature given in the three scales can be verified. Next is boiling point of mercury. 4. The boiling point of mercury is 356.7 degrees Celsius. Let us convert it to degree Fahrenheit using formula F minus 32 upon 9 is equal to C upon 5. Thus, F minus 32 upon 9 is equal to 356.7 upon 5. Thus, F minus 32 is equal to 71.34 into 9. Thus, F is equal to 642.06 plus 32. Therefore, F is equal to 674.06. Let us fill the calculated value in the table. Let us now convert it into Kelvin using formula K is equal to C plus 273.15. Thus, K is equal to 356.7 plus 273.15. Therefore, K is equal to 629.85 Kelvin. Let us enter the calculated value in the table. Next is freezing point of mercury. 5. The freezing point of mercury is minus 38.8 degrees Celsius. Let us convert it into degree Fahrenheit using formula F minus 32 upon 9 is equal to C upon 5. Thus, F minus 32 upon 9 is equal to minus 38.8 upon 5. Thus, F minus 32 is equal to minus 7.76 into 9. Thus, F is equal to minus 69.84 plus 32. Therefore, F is equal to minus 37.84. Let us fill the calculated value in the table. Let us now convert it into Kelvin using formula K is equal to C plus 273.15. Thus, K is equal to minus 38.8 plus 273.15. Therefore, K is equal to 234.35 Kelvin. Let us Please enter the calculated value in the table. Come, let us now solve some numerical examples.